I like the fact that it's getting hot on the internet.
Yeah.
Everybody's talking about glycine. Naturally, I don't agree 100% with everybody out there, or they don't agree with me. To doctors, it's like it's a supplement. They're all quackery. They're all poison. And some people think that I'm overreaching to say that, as if glycine is the be all and end all. No, actually, I'm just being scientific. You have to understand this in the context of the literature and in the context of what happens in the body. It's not meant to diagnose, treat, prevent, or cure any disease,
No.
as they say
Yeah.
with the FDA. It's because it's just a nutrient, for that key discovery, which is about inflammation. And again, let's go back to COVID pneumonia, the cytokine storm.
Mm.
What were the comorbidities? Diabetes, obesity, old age, cancer, all states in which glycine is diminished.
Yeah.
But that's only one thread of this great fabric that glycine is made of.
Dr. Brind has been very clear that he's just excited about this research and sharing it. Hi, friends. We are going to have a great discussion. It's part 3 with Dr. Joel Brind here today, and he is a biochemist. He wrote The Glycine Miracle, so he's as much a glycine expert as you can find, and not like he reads in books about glycine, like he's in the lab designing studies around glycine. And we've had a few comments from our previous episodes, which we will link to in the description, and from nutrition experts. And we welcome these comments. We love the discourse because as we ask questions, we can provide clarity and context that can get everyone just nearer and closer to the truth about glycine. So that's what we're going to break down today, the truth about the controversy around glycine. So welcome to the show, Dr. Brind. I'd like you to begin by just introducing yourself, talking about your credentials and the research you do, and why you think glycine should be on everyone's radar today.
Well, thanks for having me back. First of all, you need to know, I don't know how the date that we're actually recording this plays into it, but it actually is February 2nd, which means today is my anniversary. It is my
Oh,
54th anniversary
happy
of my
anniversary.
career in medical scientific research.
That's huge.
That's when
Okay.
I walked into the lab the first time to start my career as a medical research professional. It was February 2nd, 1972.
And
So
how many
here we
people can
are.
say that? That's incredible. Congratulations.
Right,
That
thank
speaks
you.
to your
But
extensive
that being
experience.
said, it doesn't mean everything. You can do lots of things badly for 50 years and not get them right.
Again, I love that. That
And I
humility
think
is
there are
so
probably
true.
a lot of people out there who do just that.
Yeah, for sure, for sure. You're not one of them, I'd have to say. I wouldn't put you in that bucket.
Well, I hope not. Otherwise, you wouldn't have me on. But one of the interesting things, let me just say about glycine, my being in science for 54 years, and particularly studying glycine since 2007, actually. So we're talking about around 18 years that I've been looking at glycine, and looking at it mainly from my point of view as a biochemist, not exactly just a biochemist. To introduce myself, my PhD is actually in basic medical sciences with a major in biochemistry and minor's specialization in immunology and physiology. And curiously enough, the whole key role of glycine that has been unfolding before my eyes over the last 18 years is basically the confluence really of biochemistry, glycine, a very important biochemical, but probably its most important role in the body is not a biochemical role. And this is one of the things that I think has some people confused. It is really the intersection of biochemistry, cellular physiology, right, the functioning of cells, nuts and bolts of cells, if you will, and also immunology, because we're really talking about its main effect that we can feel and that has its greatest impact in chronic disease, in prevention of chronic disease. And I say that only not as a drug, but just as a nutrient. It's a key nutrient, which has been thought to be non-essential, still is considered non-essential by nutritionists because the body can make it from simpler compounds. That is true, the body can make it, but it cannot make enough for its most important functions. That gets us to the distinction between biochemistry and not biochemistry. So everybody else, they say, oh, glycine is, it's this, it's that, it's important in making DNA, it's important in making neurotransmitters. It's very important in various kinds of biochemical reactions, in addition to being, of course, a key amino acid in collagen synthesis, because it is an amino acid. It's a building block of proteins. So people naturally gravitate to the biochemistry, especially as a building block of proteins, for its most, what is viewed to be its most important function. And I think this is really happens to miss what its most important function that we can sense in terms of our own being and our own health is. And that is that it is the body's key regulator of inflammation. It's not the only thing that regulates inflammation. It's not the only thing that can control inflammation. There are lots of things that do that, including artificial drugs that they develop every day, because inflammation is so important. But what it does is it is the trigger lock really for the very first step in a very complex cascade that can lead to everything from, from a minor little, bump or bruise reaction to COVID pneumonia, which killed millions of people
Mm-hmm.
when it's out of control. And this first step is actually controlled by glycine in one of its functions that is really not biochemical.
Mm.
It is a gatekeeper. Glycine is there in high concentrations in the fluid that surrounds every cell. You call it the lymph in the tissues, and it's called plasma when it's in the bloodstream. But in that sense, glycine needs to be present at a high concentration, and it normally is. And your body normally makes a lot, but it doesn't make enough. So
Mm.
it makes the normal concentration of glycine in the blood is about what we say between 150 and 350 micromolar. Those are just the units of concentration without getting into the detail about what that is. But you really need to have it at least 500. And you don't have to measure what your glycine is. It's very easy to do it because glycine shows up in your inflammatory response to things, which leads to what I believe is really my key discovery, my major contribution to the field, and that is about inflammation.
Mm.
That inflammation is not a natural response to injury. Well, it always happens with injury, cellular injury, which is cell death is, what you see in response to any kind of an injury, even physiological things like blood circulation, ovulation, all kinds of natural cycles of growth and decay of tissues, which involves cell death. But it's not a natural reaction to injury. It is only a natural reaction to infection. And that's kind of the half-truth that is the central prevailing dogma that everybody is kind of working on and kind of assuming, even if they don't really know it, without really diving deeper and looking at just what happens. And the reason why I did is I was really forced to because I did self-experimentation. I knew glycine was beneficial for a lot of things, and I knew that supplemental glycine would be harmless. So I just took 10 grams a day, jumped right in back in 2008. And actually, for a while, I was taking 40 grams a day to make sure that it was absolutely safe. And I took that for about 2 or 3 years before anything started to happen. And what happened was I had a serious fall onto my tailbone onto a concrete floor and literally got up and went dancing that night. And everything was fine the next day. I got a really serious sunburn, which was the kind of sunburn I hadn't gotten since I was in my 20s. And I knew I would be in excruciating pain for 2 or 3 days, just dressing, undressing, and bathing. But instead, once I got out of the sun into the shade, then the sunburn just started to fade. And
Mm.
it never manifested in that huge inflammatory response that we usually see in sunburn. So sunburn, blunt injury, it took a couple of shots to turn the light bulb on in my head and realize what was going on, that inflammation was not really a beneficial reaction and not really a normal reaction. It just it happens because most of us really are glycine deficient. Well, why should we be glycine deficient? Well, there are a lot of things. I mean, some people say, well, why would we be glycine deficient? Why didn't God make the body so that it could make enough glycine? Well, there's a lot of things we need to eat. We need minerals, right? Iron and sodium and, magnesium and all the whole host, every single mineral. Your body can't make a single one of them, right?
Right.
We have to eat those. Vitamins, we have to eat those. Essential amino acids, we have to eat those. And some things we think they're non-essential because your body can make it. It can make glycine and it can make a lot, but it
Hmm.
can't make enough to really keep the immune system under control. Well, why can't it make enough? What's wrong with our diets? Well, go back a generation or two or three in your own family. I don't care where you come from. Your grandmother or your great grandmother used to throw the bones and the connective tissues into the soup whenever you had whatever kind of animal or fish or any kind of swimming or flying or walking animal that was part of the diet. The carcass was not wasted, and what was inedible directly just upon cooking was thrown into the soup and not the trash.
Yeah.
That's where most of the glycine is.
Yeah.
No
And
wonder that dogs crave bones. Glycine good for dogs too. You can give them glycine. That's why they crave bones because we need it. And now a lot of people think again, they focus on the biochemical function. They say, oh, well, you need glycine to build collagen. So there are those who say, here's buy my glycine. It's a collagen builder. Buy my collagen. It's special type 3A collagen instead of type 2C collagen or whatever. That's all baloney. Collagen is pretty much collagen is collagen. It's about 1/4 glycine by weight. And
hmm
that's really the key ingredient. It's not really everything else that's in the chicken soup. That is wonderful for you, but that's not what is really putting a stop to excess inflammation, what's making you feel better when you don't feel well, and so on. Why bone broth does such wonderful things. Now, there's another strain that's typical in modern research and in most of the comments and most of the pontifications about glycine that you hear other people provide on the internet. And that is that they will say that glycine it does all these other things. Why would you focus? Or they would say that collagen does all these other things. Why would you focus on glycine as being the key thing? Don't you need everything? If you want to stop inflammation and it does it in bone broth, well, you need everything that's in the bone broth to do that. Well, everything in the bone broth is good for you.
hmm
But the key nutrient, the one that's really indispensable there, is glycine. And some people think that I'm overreaching to say that as if glycine is the be all and end all. No, actually, I'm just being scientific.
Yes.
Scientific research, there is a fundamental principle that is often not taught, but it is a very fundamental principle. It's called Occam's razor because it's been stated by a number of people, but it's mostly attributed to a cleric named John of Occam in England back, I don't know, 1,000 years ago. And what it says is that you need to discard any unnecessary hypotheses. It's also called scientific parsimony. So, for example, if you say bone broth, if you say I always get a terrible reaction when I get a sunburn. Well, now I started drinking bone broth a quart a day, and now the next time I had a sunburn, it didn't happen. I no longer get inflammation when I was expecting to get inflammation. Well, it must have been lots of things in that bone broth because it has other amino acids, it has other minerals, it has taurine, it has other kinds of. How do you know it's just the glycine? The reason is that if you just take glycine instead of the whole bone broth and everything, if you just take glycine, that effect will be reproduced. So glycine will provide the whole effect. So the hypothesis that you need anything else is now unnecessary. So scientifically, you need to reject that hypothesis and say, no, it's the glycine.
Yeah.
But that's only one thread of this great fabric that glycine is made of, because that's one conclusion of, let's say, a clinical trial, even if it's a one-person clinical trial.
Yeah.
That's still, what does it do when I eat it? When I eat more of it, what does that do? And you also, if you're a scientist, now you have to go into the experimental, the in vitro cell research, the animal research, and see what exactly does it do. Well, it
And
just doesn't make the inflammation go. What exactly does it do? And glycine is the great manager of what is called the glycine receptor, otherwise known as the glycine-gated chloride channel.
Yeah, and can you name the state of the science? Like, what group was doing this research? Because you're
Oh
so
yeah,
familiar.
so
Just
the
paint us a picture.
glycine-gated chloride channel has been known for quite a few decades. I'm not sure how many because it was known in the neurochemical sciences. It was known to the neurology people as the essence of the glycine receptor when neurons are uh, involved in the transmission of what are called action potentials. All right, so a nerve impulse goes down in a nerve and it connects to the next cell via a synapse. So a lot of times we know all about SSRIs and other drugs that act at the synapse, which is where the signal is transmitted from one neuron to another neuron, one nerve cell to another nerve cell. And what happens is there's a chemical signal that will um, that will continue this propagation of an electrical impulse. And the way it does that is it makes the cell membrane depolarize. Well, what does that mean? Well, depolarization is exactly what you do when you flip on a switch and you turn on the light in the room. Right? You have a light switch, you have 120 volts in the wall, which means what? It means you have two poles of the switch. The electrical potential or voltage between the two poles is 120 volts. The switch is polarized. Now you flip the switch on, what happens? Now you've connected them, right? You've jumped jumped the connection between the two poles of the electrical switch. Now the electrical potential between the two poles is zero. You have depolarized that switch, the light goes on. So now the same thing happens in cells. If you have the kinds of cells that do inflammation, they're called macrophages. They're cells of the immune system's first responders, like the cops and the firemen out there in society, the first responders. So in case there's any injury or any infection, these cells come right around. But there is a switch that turns them on to the status that's called M1, where they actually do inflammation, where they start secreting poisons, which can destroy normal tissue, but it's there to destroy things like bacteria and fungi, which have gotten in and infected you to kill them before they kill you.
Mm.
Right? So that's what these first responders do. And so it acts like a trigger lock because unless there's a bad actor present, the cops aren't going to start shooting up the place, even though they're armed, right? Cops
Hmm.
show up to an accident, they still got guns in their holsters. So they are armed in the same way macrophages can arm themselves if they detect the signature of a bacterium, let's say. There's a standard one used in the laboratory called lipopolysaccharide, which is sort of a universal signature of a bacterial polysaccharide coat that's outside its cell membrane. You have bacteria in your internal fluids. I'm not talking about gut bacteria where they belong or other quasi-internal passageways that are really not the internal compartment of the body. But you get into where the cells are, where the blood is, and everything like that. You're not supposed to have any bacteria there. And if your macrophages see any of them, they will get activated and you'll have inflammation to try and destroy the infection. And it usually does very well when there's an infection. The trouble is whenever there's an injury, even a micro injury just from blood circulation, just from, clap your hands, you got micro injuries
Yeah,
right
yeah.
in your hands. All of these things will elicit inflammation if there's some derangement that these macrophages get activated. And they get activated because that switch at the surface of the cell membrane, it's like the whole surface it's a cell surface wide switch. Outside versus inside is going to be plus 0.07 volts, not 120 volts, 70 millivolts approximately on average, as much as we can figure. So the inside is negative relative to the outside. Now, what happens is when there is any kind of injury, these macrophages, they come around and they clean up the mess, like the police do when they show up to an accident scene, right? So they call the tow trucks and haul away the wrecks, and they call the ambulances to fix the wrecked bodies, get them to the hospital, and they take accident reports to find out exactly what happened, and all that kind of stuff. That kind of thing. Um, so that goes on. The but what doesn't happen is that they don't pull their guns and start shooting up the place. And that's because that switch, which gets them to do that, which the M1 switch, which turns them into N mode, N1, macrophage 1 mode, doesn't get turned on because in order to turn that on, what needs to happen is the depolarization. Well, in the act of doing that phagocytosis, acting like little amoebas and cleaning up the mess, and especially when a cell is very active, that switch it gets activated because there is a deterioration in the voltage because ions, which are electrically charged dissolved solids, will naturally sort of leak in and leak out as the membrane's moving around doing its activity, especially when it's cleaning up the mess. So the membrane polarization kind of naturally leaks out. And what the cells do to prevent that is there are pumps that are constantly pumping, for example, sodium ions out and potassium ions in. Why? Because sodium ions are usually high on the outside, the resting state, and potassium is high on the inside, and vice versa, high and low. And so, if for example, if you have a ship at sea, right? Um, if you go down into deep in the hold of the ship, what do you find? A bilge pump. What's that? It's a pump that's constantly pumping out water. Why? Because the ship's at sea, there's always some water splashing in.
Mm-hmm.
And so, and if you don't have a pump that's constantly pumping water out, eventually the ship is going to sink
Mm-hmm.
because you got to get rid of that. So the same thing is true with the cell, and with a cell that can be activated that way, if the depolarization happens enough, if that voltage deteriorates, it's very prone to be inappropriately activated. So not only are the pumps going on, they're called the sodium potassium ATPase pumps, but there's also ion channels, channels which selectively will let certain ions diffuse in and diffuse out. Diffusion is what happens if you have a channel where sodium and potassium can freely flow through a little tunnel, well, guess what? All the sodium's going to flow in and the potassium's going to flow out because if nature abhors a vacuum or a difference and it's going to try and make everything equal.
Mm-hmm.
Well, the same thing happens with chloride ions. Chloride ions are also high on the outside, low on the inside. And chloride ions have a negative charge. So if you have to open the appropriate number or an adequate number of chloride channels so that chloride ions can diffuse in, what happens then? When chloride ions diffuse in, the
Hyperpolarized.
voltage gets higher because it is a negative charge and the resting voltage is negative on the inside. So the membrane becomes hyperpolarized. It can keep that 70 millivolts or so if it has enough chloride ions leaking in. Well, guess what is the gatekeeper? Guess what the little hands are that turn that valve on this chloride transporter or this chloride channel? It's glycine.
Yeah.
Glycine gated because glycine is the gatekeeper of the chloride channel. And
Okay.
ordinarily, you just need a lot of it. The cell is bathed in high concentrations of glycine, kind of like a salt, just part of its environment, not something that's doing a biochemical function. It's not being incorporated into protein. It's not being broken up into pieces used to make DNA. It's that function of glycine where it is a gatekeeper
Mm.
for those chloride ions. And if it's not in adequate concentration, the gates are not adequately open so that the voltage, the membrane resting potential then deteriorates and you get inappropriate activation. And this is what happens when you get only the level of activation needed to get them to M2, the clean up the mess or the mend mode rather than the rend mode, I call it. And then you get inflammation.
Yeah.
And so inflammation is a typical characteristic response to injury. We all see that. We all know it. It's always happened to all of us every time, pretty much,
Yeah.
because we're glycine deficient. And by the way, I had a very interesting conversation with a friend of mine about a year ago. And I was trying to tell her all about Sweetamine, the glycine supplement that I sell. And she said, so I was telling her about it, and I was telling her that you can get glycine, for example, as a component of collagen. So if you have bone broth, she said, "Oh yeah, I'm a real bone broth enthusiast. I have bone broth every day." And she's got white skin like I do. I said, "Oh, you ever get sunburn? I go out in the sun all the time." I
Mm.
said, you ever get a sunburn, that hurts and flakes? And no,
Mm.
never bothers me.
Isn't that interesting?
So she's not glycine deficient. So there are people out there who aren't without taking a glycine supplement, but
Right.
it's very unusual to have a diet that really is adequate in glycine. And it's for a number of reasons that kind of add on to each other. So for example, if you don't have enough glycine because you're not eating the bones and the connective tissues and you're only eating the muscle meat, well, that's one strike.
Yep.
But if you're also eating a lot more muscle meat
Hmm.
than people used to eat all the time, because now we're kind of an overfed society, then what happens? Well, when you have too much of that essential amino acid methionine, in which the muscle meat is rich, your liver needs to get rid of it. So instead of going through what every biochemist learns in school about the methionine cycle, how the liver recycles methionine, regenerates it from homocysteine, puts the methyl group back on it with folate and so forth, it's not doing that. Right the hour after you've had that cheeseburger, and you're absorbing all of that methionine, your liver is busy getting rid of it as fast as it can, actually, because it doesn't need much methionine. Essentially, yes, but it's so good at recycling it and regenerating it that you only need, like 500 milligrams a day. It's almost like a vitamin than a bulk nutrient, but glycine you need a lot of.
Yeah, you
So,
said around like 8 grams of glycine a day is where most people, because we used to eat, what do you think? What is our historical consumption? What's our consumption today? And what's an optimal consumption?
right. So historical consumption probably is between 2 and 3 grams of glycine a day in the diet. And that's a lot.
Yeah.
That's a lot. And you have a lot in your body, but not enough because and there's actually a group, that is based in the Canary Islands that about 10 or 15 years ago did some very good biochemical work on how much the body actually needs of glycine in order to perform all its functions and not to run short. And they said about 10 grams a day. And
Okay.
in my experience, I found about 10 grams a day.
Yeah.
If I, and you get about 2 or 3 grams a day from the diet. So that's why I formulated my sweetamine to have 8 grams of glycine, which is a very good average. If you have 8 grams a day of glycine taken in, it really is enough. A lot of people say, oh, 2 or 3 grams a day is already therapeutic, and it is, considering how glycine deficiency is so common.
Yeah.
Even not quite the full complement is enough to make a difference in your status in terms of inflammation and everything. But that's the second reason, though, that that the glycine deficiency is exacerbated with the current diet is by eating a lot of muscle meats. You have to get rid of all that extra methionine. The only biochemical pathway for getting rid of excess methionine is, guess what? It's called glycine N-methyltransferase. It actually uses up 2 molecules of glycine for every molecule of methionine that's gotten rid of. One of them it needs to make glutathione, but that's a way of getting rid of it from the point of view of having excess methionine around, because glutathione is a way of limiting the damage from methylation reactions, which is a high energy reaction that methionine is used for.
Hmm.
So when methionine is activated and then used and it methylates stuff, it creates a high energy thing. It creates an increased demand for glutathione, the
Hmm.
body's most potent antioxidant that it makes. And isn't that wonderful that it's coordinated perfectly with getting rid of methionine, more glutathione.
Yeah.
Anyway, you need that molecule of glycine to make glutathione and another one just to clear away that extra methyl group. So now that you're eating more muscle meats, you're actually stripping the body of glycine. So now that's 2 strikes. We're ready for strike three. There's got to be another strike, right? Well, now that we're
I'm
eating so
ready.
much of everything, what's happening? We're getting fat.
Yeah.
And what happens when you get fat? Well, this is a fairly recent discovery by a Mayo Clinic team in Minnesota and also at their branch in Florida, that when you, and I think there's some other people too, I don't want to not give enough people credit, but it's fairly recent in the last couple of years. You can read about it in my book. I summarize this, that that obesity actually shuts down one of the key pathways for the synthesis of glycine. So that your body is not only does it not make enough, but if you get fat, it's making less. So obesity now, less glycine is being made. And especially if it's a result of less glycine being consumed because you throw the bones in the trash and you're eating more and more of the muscle meats, you've got three ways that glycine is being reduced. So if you were having enough glycine before, you don't now. Another thing that was pointed out by one of these other fact checker types, I guess, on the internet was saying that oh, there's a study that shows that glycine may be bad for you because and they show a study
The stroke. There was the
the
this.
study, yes, a study that was done in Japan, a good
Yep.
study, perfectly good study correlating diet with stroke. And they said, oh yes, people who eat the most glycine, actually the quartile, the group, the quarter of the study population that ate the most glycine compared to the study population, the quarter of it that ate the least glycine, they had like a 20% increased incidence of stroke. It's like, dying of stroke. So you look at this and you say, it looks like it's bad. I don't want to touch glycine. It's bad to have it as a supplement. But you have to you have to understand this in the context of the literature and in the context of what happens in the body, which was actually elucidated by a group at Oxford in the so-called EPIC study, European prospective investigations on cancer, I think. They had a multinational study in Europe. Well, in the UK, they had a group that did a branch of this study studying glycine and studying actually amino acids, all the amino acids. So they took 100 vegans and 100 lacto-vegetarians and 100 fish eaters and 100 omnivores, meat eaters, and they looked at everything they ate and they looked at everything in the blood. And generally, if they had more, if they had more leucine in the diet, there was more leucine in the blood. If they had more valine in the diet, there was more valine in the blood. All the amino acids correlated pretty well with what you ate and what you had in the blood, except glycine. They couldn't quite figure that out. They should have been able to figure it out, but that's what they found, that about 20%, there was about a 20%, before we get to percentages, the people, the group, the quarter of the population, of the different kinds of diets, the diet that had the most glycine in their blood were the vegans. Now, that might not mean much to you, except for the fact that the meat eaters had the most glycine in their diet. Why? Because meat, fish, and poultry, very high protein. Even though they're muscle meats, even though they're relatively glycine poor, when you eat meat, fish, and poultry on a regular basis, you're going to have more of all the amino acids in your diet.
Mm.
But the balance is what tells all, is what's in your blood. So in this study that's just been cited by this fact checker about showing that the group that consumed the most glycine had the greatest risk of death from stroke. Guess what? They ate the most meat, fish, and poultry
Yeah.
because because that's where most of the glycine is. So if you just take the absolute quantities and you
Mm.
just measure what you eat, so that study measured what they ate and they correlated that with a disease outcome, stroke,
Rather
death from
than what's in
stroke.
your body and what your
Right.
body's using and doing with it.
Yeah, and not addressing, apparently oblivious to the fact that in 2015, this group from Oxford had just shown that there is a big disconnect in terms of glycine, which they were looking at, a big disconnect in terms of glycine between what you eat and what is in the blood, right? So you have what
Mhm.
you eat, what's there in your body as a consequence, and what disease outcome may come down the line. So in one study, they looked at what you eat and what's in the body. Another study, they looked at what you eat and the disease outcome without looking at what was in the body. And so
Yeah.
it's completely irrelevant. It doesn't matter how much you eat if it's in the context of a diet that doesn't balance enough glycine with especially the methionine that's eaten
Oh,
in the
beautiful
diet.
point. And can I just interrupt to say one thing? They also mentioned that you had, or we had suggested that the reason vegans are healthier is because of their higher glycine levels. But I don't think were saying that in the original interview. Vegans can be healthy, omnivores can be healthy, and we're not saying it's because of only
Well,
glycine.
no, exactly right. I think, well, the thing is, glycine in that context, it's just an essential nutrient. So the idea was that meat eaters who don't eat the whole animal, nose to toe, they say, right? If you don't, then you're going to have more of a deficiency that the vegans won't have.
Right.
So yeah, it might very well be the glycine that makes the difference because there is going to be a difference. The vegans have more glycine because they're not stripping it with the high methionine intake. And there's a relative high glycine content after all. If you eat a lot of soybeans, the botanical name for the soybean plant is glycine max. Kind of tells you it's high in glycine, right? So
But we are also acknowledging that vegans might be healthier and omnivores might be healthier for other
for other
reasons
reasons, yeah,
too.
lots of other
Yes.
reasons. But if you
Yes.
say, if all other things being equal,
Yeah.
there is this one essential nutrient which the vegans are going to have more of than the meat eaters. If that's the one thing that's different, then that's going to make the difference in the health outcome, right? So, but
Yep.
that's different from saying, oh, just eat glycine. Yeah, I could just eat glycine all day and nothing else, and I should live to be 100. Well, I probably won't live to be another 2 weeks old, actually, if I just take glycine. Yeah, well, there are a lot of things you need to eat. It's like if you take a supplement, people say, oh, do I need to take this for the rest of my life? Well, you need to eat for the rest of your life, right? I mean, it's food. It's food that you need every day. It's
Yeah.
an amino acid that's the smallest, the simplest, the most water soluble amino acid. So it goes through you very quickly. It
Yeah.
has a biological half-life that's measured in hours, not days. And so typically, like people who buy my sweetamine, my glycine supplement product, a lot of times they'll buy it and they'll try it because why they have aches and pains and things, which usually, more often than not, are largely a result of inflammation. And as I tell them, the same thing that happened to me is that pretty much you start taking it on about the third day of use, you'll notice that those aches and pains seem to be gone. And then you go off to see if that's, I don't know if that's what really did it. Because again, it's not a drug, it's just food. It's just
Hmm.
takes a little long time, a few days, to kick in, the balance in your nutrients. And then they go off it. And then sure enough, 2, 3 days later, the pain comes back. So it's, you, 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 uh,
Oh,
you
and
realize that that's what it is because it's a very short half-life and you need it every day. And you don't have to get it from me. You can get it from bone broth. You get it from
gelatin.
Paleo Valley bone broth is a great place to get glycine.
It's a great place. You can also get it from gelatin, right? You can
Gelatin,
do
sure.
use a slow cooker. You can make your own bone broth at home. You can
Right.
do oxtail, these more like collagenous cuts. I mean, you can do soybeans, you can do pumpkin seeds. I mean, we are like, I think Dr. Brind has been very clear that he's just excited about this research and sharing it, and that we want to fill the glycine gap however you choose to
Right,
do it,
because
right?
it is the key nutrient among most of those that we're studying. It is a key. That's what Occam's razor tells us. When you find out that glycine alone can control inflammation, and we know now, we know the molecular mechanism.
Yeah.
Then there's another thing that happens, of course, I guess when you're talking about COVID pneumonia, people dying from COVID pneumonia, that cytokine storm, that's really end stage inflammation.
Yeah.
And end stage inflammation is often manifested or has been manifested in the past as what they call toxic shock syndrome. Somebody's admitted to the hospital now. They have a systemic infection that's now in their blood. So the survival rate from that is like 20%. I mean,
Wow.
that's usually, you're out the door when that happens. It's a very dangerous situation. And in animal studies, I don't think they've tried it in hospitals or anything yet, but in animal studies, they give them glycine, they come out of it.
Wow.
Because glycine, and yet that's way the end of inflammation. Never mind that first step of inflammation that's controlled by glycine. This is at the very end. Glycine can stop that too. Well, that's some research that was done in the 1980s.
Wow.
A brilliant investigator named Joel, actually Joel Weinberg, who's retired now from University of Michigan, he was actually a transplant guy, was studying how to keep kidneys from going necrotic, trying
Mhm.
to keep them alive and functioning between the donor and the recipient. And he found out that glycine was able to sustain them and found out why, that it is that end stage of inflammation that's protected by glycine and others, also The Ron Thurman group in UNC, University of North Carolina, also saw that in toxic shock, and that it was able to prevent this end stage of inflammation. So
Mm.
there's a head scratcher. If it has nothing to do with the glycine receptor when it's preventing toxic shock or a cytokine storm, how's that working?
Yeah.
Well,
How's
guess what? It's still glycine, but there's another substance with which it interacts in this cellular physiological control situation. That's something called what's it called? Mm, I just learned about it a year or two ago. It's in my book now, but
is it it's not pyroptosis.
not. It blocks pyroptosis,
Mm.
but it is the substance that's on the cell membrane.
Oh, I remember it. Let's see.
Yeah,
I know I
something.
remember reading about it.
Yeah, it has a letter there. It says,
Yeah, it's like a J something P. I don't remember, but yes, I
yeah,
remember. We can put it in the notes.
yeah. We'll put.
Yeah.
Sorry,
Yeah.
but it has an interesting name to it. But when in the very end stage of inflammation, when those macrophages go nuclear and they literally blow up, they fill up with water, they swell, and they burst. It used to be thought that that action was because now they have these pores in them, they're taking in water, and that makes them burst. No. It makes them swell up. It makes them all these blebs come out, that they're all full of like bubbles on the outside, but they don't burst unless there's not enough glycine around.
Isn't that
And
incredible? Yeah.
yeah, and the glycine then keeps them from bursting. So it controls the very first step of inflammation, the very last step, the end stage step of inflammation where you have pyroptosis. And it also explains the reason why in ordinary physiology, why it's self-limiting. So scientists, they say, oh, inflammation. We know inflammation is an important function and all of that. We just don't know why it becomes chronic.
Hmm.
Why is it not self-limiting? It's usually self-limiting. Well, to tease apart that question, it's the first thing is that usually it's not appropriate or it's excessive
Mm.
because there's not enough glycine around and more inflammation is begun. More inflammation, more inflammatory reactions start all over the body with cells of the immune system. Macrophages are all over the place. And so that's one reason why you have chronic inflammation. But the reason why you would have inflammation, even if there's not enough glycine around, and then it becomes self-limiting. Why is it self-limiting? Well, you know what else besides these sodium, potassium, ATPase pumps are on the surface of cell membranes? There are also glycine pumps that
Mm.
do the same thing with glycine. They pump glycine into the cell. So
Mm.
if you look at the glycine level in your blood, you said you're talking about the blood plasma level, but if you look inside the cytoplasm of the cells in the blood, it's much higher. It's
Mm.
like 4 or 5 times higher, I think,
Mm.
a few times higher than it is in the blood plasma. Well, that's interesting. Well, I guess the cells need it inside because they need glycine biochemically and so on. But what it means to inflammation is what? It means once you get that end stage, that pyroptosis, now the cells are blowing up and they're blowing up their all of their inflammatory mediators are being sprayed all over the place, causing more and more inflammation. Guess what they're also doing? They're also unleashing a higher concentration of glycine in the local area.
Mm.
Guess what? Self-limitation.
Yeah,
Now you
quietly.
have more and more glycine. So now we go to a situation where that happened. Again, let's go back to COVID pneumonia, the cytokine storm.
Mm.
What were the comorbidities? Comorbidities were what? They were diabetes,
Yeah.
obesity, old age, cancer, all states in which glycine is diminished.
Hmm.
So when you get to that point where the glycine is so low, even inside the cells, it's not high enough to overcome that cytokine storm and that end stage toxic shock, or however it manifests in the whole body reaction, you're dead. Again,
Yeah.
not enough glycine, not enough glycine at the beginning, not enough glycine at the end. It really is that kind of magical stuff. It really is a miracle. That's why I call the book The Glycine Miracle.
Yeah.
But, I'm not the miracle worker and the only purveyor of the stuff you need to make the miracle happen. You get it from anywhere.
Yeah.
Certainly.
I know. And I think it's so important, like you said, glycine's having a moment, but not everyone's talking about this particular
Right.
application. And I went through our comments, and people are saying, sleep improvement is huge one, lower back pain improvement, allergies, even faster recovery, less bathroom breaks, less anxiety. I mean, it is a powerful, powerful thing when you bring glycine back into your diet. But I wanted to, another one of the things, the myths that we have to bust is when we talked about this Cruz research where they gave people, I think
Right.
it was 5 grams of glycine 3 times a day, people who were
Yes.
diabetic. And we looked at there was a lowering of HbA1c, but there were also a lowering of, I believe it was TNF alpha. Now, interferon was increased. TNF alpha
Interferon gamma.
went,
Yeah, that's
yeah,
anti-inflammatory though. Yeah.
exactly. So, this particular YouTuber was saying this doesn't paint a picture of anti-inflammation across the board. Some
Oh, yeah.
inflammatory
Well,
markers went up and some went down. How is there a specific marker you can tie to this
no, I think
anti-inflammatory effect?
here's what I would say in
Yeah,
response to that, because I remember that discussion that this particular fact checker had,
yeah.
self-appointed fact checker had on his criticism of the Cruz study. That's from 2008. And I would say this first, I would say in general that it may be that a lot of people like that, they're kind of sloppy. They're kind of hit and run. They say, look at studies, or maybe even if they have AI, look at studies. And, this study says this, that study says that, and I've looked at all this. But yeah, you got to look at them a little more carefully. So, for example, this particular YouTube critic showed a chart. What this fact checker showed, he showed a series of figures from the Cruz study, which showed four inflammatory markers. And he pointed out how, well, it's not really clear, it's not really that significant, it's not really that. And he was talking about diabetes. And then he went on to say how, in a really good study, you could see the change in A1C, which is the hallmark of, diabetes manifestation. Well, in the Cruz study, they measured A1C. For some reason, they didn't feature it in a figure. They kind of buried it in a table. So what
Mm,
I did is I made a figure out of it. Here's the figure. If you look at this, there's two data points on the left and two on the right with error bars. And the ones on the left, the baseline, it was the start of the study with those that are glycine treated and those that were the controls, they were the same because nobody's been treated yet, right? These two. I don't know if you can see my cursor.
yeah, I can.
Oh, okay. So those are the same. That's the start at the end of the study. Here's the control. And here's the glycine treated one. It's almost out of the diabetic range. They lowered the average A1C from 8.3 to 6.9.
Mm,
Now you might say here, oh, okay, there's a placebo effect also. But that's one of the toughest things about doing a study like this, and one of the reasons why this study is so key. When you do a study, and I don't know if AI picks up on this, but when you do a study with actual people, and you have people who are diabetic, and you say we want to test the hypothesis that if you take 15 grams of glycine a day for a month, it's going to help your diabetes. Well, that's fine. But what about the medication they're already taking? Most of them are already on metformin. Can you say,
mm.
okay, stop taking your metformin? And
No.
if you happen to get a heart attack because you're unmedicated, well, that's life, No, they don't say that. You have to let people keep taking the medication they're taking.
Hmm.
So a lot of this so-called placebo effect is actually what's called in clinical trials a compliance effect.
Mm,
Now that they're being studied clinically and they're on this particular drug for this particular condition, usually metformin for this particular condition, diabetes. This is in Mexico, 2008. I think they had metformin then. So what are people in the study going to do? Generally, they're going to be more conscientious about taking their medication every day.
yeah.
So most likely their diabetes is doing a little better just because they're taking their medication regularly, or it may also be placebo effect. Regardless, it's very, very hard to find a statistical difference when you're testing someone to help their condition when they're already taking a drug to help their condition,
Mm,
right?
yeah.
So here they are. So the A1C went, I guess it's 90 days because A1C doesn't, that's a
Yeah.
90-day
It's a
indicator
three
because
month. Yeah.
it's about red blood cells, which have a 120-day half-life. So but this was clearly significant from 8.3 to 6.9. And I've had lots of customers over the years who also confirmed that that's helped their A1C and so on. And I would also say that this also brings up another point. In the face of the accusation, if you will, that, it's all about glycine and nothing else. That diabetes is a glycine deficiency disease. If you have enough glycine, you'll never get diabetes. Well, that's not true of any disease. I mean,
Right. And he
uh,
was mentioning that you were saying it was primarily an inflammatory condition, but that he was suggesting it also has a metabolic component, which I don't
well,
think you
yes,
ever argue
well, it
with.
has a metabolic component. I mean, it's like, but this is also true of any disease. You have to remember. I mean, you can say, measles is caused by the measles virus, but how come everybody exposed to it doesn't get measles?
Yeah,
Not
right?
universal, how come this is actually true of Ebola? Ebola virus, we were all scared to death of Ebola, right? That was supposed to kill you so gruesomely and so quickly and so on. And, so somebody had Ebola and he was exposed to a family someplace in Atlanta and he was throwing up in public. And oh my God, we thought there was going to be a local epidemic. Who got COVID from him? Who got Ebola from him? One nurse.
Wow.
And they cured her. I think she ended up suing the hospital anyway, but one nurse got COVID and she got better, from that one patient from Liberia who actually had not COVID, but again, Ebola. But the thing is, most people who are exposed to Ebola don't get sick.
Mm,
Why? If Ebola causes this disease, then, that's the only cause. Well, obviously. The pathogen is not the only cause of any disease, or the key nutrient is not the only cause of any disease that may be a deficiency disease,
right.
or in part a deficiency disease. So, for example, I use my own situation around the time in 2007, right before I discovered all this stuff with glycine. My boss, who was also a doctor and my mentor, we used to test our blood every week. We had a blood club going. We used to draw our blood every week, and I ran the laboratory. We used to test everything, all kinds of stuff, biochemical stuff, hormones, everything. Not everything that can be tested, but a lot of general stuff, thyroid hormone and androgens and estrogens and all of these things. So. We used to test that all the time, and my fasting glucose was creeping up, creeping up. It came out 129, which is anything over 125 is considered diabetic, and between 110 and 125 is like impaired glucose tolerance. So it
Mhm.
was right around that impaired glucose tolerance area for a while, and then it started tracking into diabetes territory. So he said, I think you really ought to start taking metformin. Well, I put it under advisement. I didn't do it. I said, well, I think I can manage it with diet. Soon thereafter, I started experimenting with glycine, and that was like, for 17 years. I stayed in that impaired glucose tolerance area. Well, guess what? Last year I walk into my GP here in Arizona and he says, well, your fasting glucose is up to 127 and your A1C is 6.8. You're really into diabetes territory now. So I said, well, all right. And I was still, taking my glycine. So it kept me out of diabetes territory for 15 years, but eventually caught up with me because I was still 20 pounds overweight. I said, it's okay. I'll lose the 20 pounds. I lost the 20 pounds. I'm not diabetic anymore.
Mm.
Okay.
So you're
So
saying
yes, it's
both.
multifactorial. Yes, the weight does matter,
Yeah.
but it does, it's more, it's largely, and when we talk about blunt injury, that inflammation is not a natural response to injury. You're still getting injured. You still need repair things to go on. There are still effects from that injury. It might still hurt unless that pain that they're experiencing is from inappropriate or excessive inflammation due to glycine deficiency.
Right.
Glycine won't help. Sweetening
Yes.
won't help.
Yes.
So
It's just that it's
I'm not trying to be the absolute, glycine is, it's the cure-all of everything. It's not. It doesn't prevent you from didn't prevent me from getting diabetes, didn't prevent me from getting shingles.
right.
2015, I had been taking glycine for what, 7 years, and I had shingles, a classic case of shingles. Here I was, 64 years old, and one day I get in the shower, and I realize I have shingles. Why? Because I was soaping myself up in the shower, and I felt with my fingers, I felt these bumps, and I looked. put another mirror so I could see my back, and there it was, lower back, unilateral, characteristic rash. And I didn't feel a thing except with my fingertips, I could feel the bumps of the rash. Had it checked out by a neurologist who said, "Yep, you got shingles. It's absolutely classic." And it was in every way, except guess what? No pain.
No pain, which is so amazing. And that's one of the
And I've
questions.
had other, yes, customers tell me that too. Some who've had excruciating pain from shingles.
Yeah.
For some reason, it will stop the pain of shingles. It will stop the pain even of poison ivy, a severe allergic reaction, which I'm very sensitive to. And I tested it once because I used to be really sensitive to poison ivy. So I used to go around like with plastic gloves on, when I found poison ivy on my backyard or front yard, I would go around the property and pull it out, surgically and all of that because I just didn't want to get run into it, accidentally in mowing the lawn or whatever I was doing. And so and I noticed after I started taking glycine regularly for some time that I know that I've sort of casually made, I think I brushed a little poison ivy, uh-oh. And a day goes by, two days go by, I get no reaction. So I'm thinking, is glycine making me less sensitive to poison ivy? So I did an experiment, another self-experiment. Not always the most advisable. Don't necessarily try this at home, but I put a glove on my right hand, plucked a poison ivy leaf, and in the back of my left hand, rubbed it real good into my skin, and then just washed it off normally, not with any special solvent or anything. Sure enough, a couple of days later, I get that right there on the back of my left hand. I get that characteristic, ugly, white, bumpy rash from poison ivy, and it itched a little, but just sort of when it erupted. And then it just sort of stayed that way, like poison ivy does. And it didn't really bother me. Why? Even though it lasted for about a week before it went away, it didn't itch,
Mm,
didn't bother me,
yeah.
So just like shingles, I got shingles, I got poison ivy, but they didn't bother me. So it doesn't, it's just a matter of taking care of this often because a lot of the inappropriate inflammation is a secondary reaction to some other insult.
Yeah.
Like it could be an infection or an allergic reaction or something, but that secondary inflammation is stopped.
I think
So
that's
that
great.
helps in things like, even genetic diseases like cystic fibrosis.
Mm.
A lot of the problem with cystic fibrosis is, secondary inflammation in the lungs. That's what really does more of the damage than anything else. Well, I tried to convince some people I knew had kids with cystic fibrosis, and they're very, well, their doctor says don't take any supplements. To doctors, it's like a supplement is a
And
supplement is a supplement. They're all quackery. They're all poison. They're all, something. There's a lot of these armed camps in the biomedical field now, and I don't
yeah.
want to be an armed camp about glycine. I just want people to know what's actually true about nutrition in their own body, and it's certainly something.
What about
Decided to
autoimmune?
sell it because it's cheap, it's easy to take, it's completely harmless, and it's and making it a business provides people an actual opportunity to try it rather than burying it in the medical literature for another 24 years, 20 or 30 years before somebody actually finds out about it. So now I like the fact that it's getting hot on the internet.
Yeah.
Everybody's talking about glycine. Naturally, I don't agree 100% with everybody out there, or they don't agree with me.
Yeah.
I think people are still reluctant to, for that very, very, very key discovery, which is about inflammation and
Yeah.
glycine. That inflammation is not an appropriate reaction to injury, just infection. That has nothing to do with any of the other wonderful effects of glycine about helping you sleep and, you
Yeah.
know, uh, all the other things, muscle recovery and so on. Although muscle recovery, again, that's a story about inflammation.
Hmm.
Because muscle recovery has to do with when you do vigorous exercise to build muscle, what happens? The pain
There's
that
it.
gives you the
Yeah.
gain, that's actually the tearing of muscle fibers. And that induces the muscle to remodel and build back better, build back stronger, right?
Yeah.
And if you don't have enough glycine around, that exercise, that tearing of the muscle fibers will cause inflammation. And the next day that gives you pain. like it used to, when I was in my 30s and we'd have a big snowstorm, I'd shovel snow for an hour, and the next day I could feel it. But once I was in my 60s and I
Yeah.
shoveled snow for an hour, the next day I felt fine because I was taking sweetamine every day. I was taking a glycine supplement.
I
So
love
it makes a big difference in a lot of things. It also makes the kind of difference you can feel. And when I say a lot of things, these are, the chronic diseases that make most people sick and die these days that are really due to not having enough glycine to be able to deal with the stress and or the actual disease condition itself. Because, but it's not a drug, right? It's a nutrient we just don't get enough of. Almost everybody needs to take more, unless you're a bone broth enthusiast, and
it.
you can get it from bone broth, from food, you get it from gelatin.
Like I said, so many of you have already listened to the previous podcast and told me about amazing results you've been
Oh,
having.
good. Yeah.
Oh,
That
so
wasn't too
many.
long ago, so they're feeling it now already. That's good. Yeah.
They really are. And do you have a time for a few Q&As? So, do you feel like we've appropriately answered all of the criticism? There was one thing about the certain specific inflammatory markers went down, but not all of them. Do you think in that Cruz study, do
Oh,
you,
well, the Cruz study, they don't even measure all the markers. They measured a few of them.
yeah, there's like four of
And
them.
again, that was, I think, just part of the inherent difficulty of doing a clinical trial in a population where you are investigating, some intervention, and you have to do it ethically, and you can't prevent them or stop them from taking the drugs they're already taking. And it's the kind of thing where if you really had a virgin population, if you will, in
Yeah,
terms of, somebody who walked in the door and said, "Oh, you've got diabetes, try this," before they try anything else, you
I
know,
see.
that
Yeah.
that's a different story. And I think that's just inherent to the study design. It was a pretty good study and really amazing that of all of the markers that popped out, nothing was more dramatic than A1C. And this fact checker didn't even notice that they had addressed A1C. He went to another study where they looked at A1C because I think
Right.
it's just kind of this drive-by commentary. Oh, I got another podcast to do. It's Tuesday, time for another podcast. You got a quick, how many studies do this, do that? Have AI help me. AI says, well, we looked at all these studies, and AI is,
Oh, so
it's going to
inaccurate.
multiply the kind of tasking that it's trained to do. So it's a matter of how you train it. And
Okay.
I don't know if it's even possible to train it to really, I don't know if you can give it 54 years of experience of scientific research,
No, I don't think
working
you
in the
can.
laboratory, in the classroom, in the literature and all of that. So I'd like to think that the experience counts for something.
Oh,
And as I say, I've only been working on glycine for about 18 years, but that doesn't mean that all of my previous experience wasn't brought to bear. Uh,
no.
and
And
so I'm just trying to share it. That's all I wanted to do.
yeah.
And that's why I started the company. And the more money that's made, the more goes into advertising, right? So I can, get
Oh,
it to
yeah.
more people can try it. Just try it. I just want you to try it. Well,
Yeah,
why don't you give
just
it
try.
out free? Because you know why? Because then you won't try it.
Yeah. It kind of gets lost. It's
Oh
true.
yeah, I'll take 10 of these, but they
Yeah.
won't try it.
Yeah.
They won't even bother because you don't, as we were in the 250th year of the American Revolution, I'll give you an American Revolutionary slogan from Thomas Paine, who was the great pamphleteer who whipped up the American colonists into a frenzy against the British in the 1770s. And Paine, I quote Thomas Paine because I think he said it in the most efficient way that I've ever heard it expressed. He said, "That which we obtain too cheap, we esteem too little."
I love it.
That says it.
Well said. So yes, everybody
Yeah, I
go
thought it was
out
great
and
to say it that way.
I thought you did too. So try that. You can try the bone broth. I have a video coming about how to fill the glycine gap. But also, can you do a few more questions? Because we have
Yeah,
specific
sure.
questions.
Yeah.
People are so excited. So there was one from Tommy, and he said, if I understand one of the mentioned mechanisms correctly, glycine prevents inflammation. Why is this not a problem when inflammation is beneficial for infection? Maybe glycine prevents inflammation in only in certain situations.
Right.
If so, which and why? I don't think that was explained.
Yes, it prevents inappropriate inflammation. In other words, when that cell is activated to go to M1 inappropriately, it
Mm.
will go to M1 appropriately when it sees the appropriate marker. If you're looking for the research for that, there's an excellent review published in 1999 of the work of the Thurman Group,
Nice.
where they show you the cellular electrophysiology of glycine and non-glycine when the white blood cells, when the macrophages, these are alveolar macrophages, are presented with a standard laboratory model for the bacterial infection provoking, which is called lipopolysaccharide. They put lipopolysaccharide, bacterial LPS, they call it, in the medium. You can see that they react, and you can see the electrophysiological jump. It's like a big surge. Um, Here you have the lipopoly. These are isolated Kupffer cells. Kupffer cells are liver macrophages, in particular, from the liver, not from the lungs in this particular experiment. So this is the effect of glycine on lipopolysaccharide induced increases intracellular calcium. That's a marker for the activation of this macrophage. And you can see when there is, and how much glycine did they have? 1,000 micromolar. So that's 1 millimolar glycine. That's a lot. If you eat glycine, you take 8 grams every day, you're not going to get up to 1,000. You get 500, 600, right? But
Hmm.
here's even 1,000, higher than you can get your glycine by taking a daily supplement. And you can see that that indication of response. So that's now going to go after that bacterium because it saw that LPS, it saw the signature of a bacteria. You still get the response. It's just not crazy
Oh, I love it. I
like it
love
is
it.
when there's no glycine around, you see.
Oh, I love that. Thank you. And I actually, you might need to use this slide. I have one other question. Somebody, and we've addressed this in other podcasts, but I think you have a slide that you might be able to show here. People were saying that GLYNAC was superior to glycine alone. Um,
Well, yeah, it might be if you need
Cysteine too.
cysteine, yeah. Well, and GLYNAC's it's a very interesting situation. I'm going to look at it a little more. So this is the group from Baylor. This is Kumar and Sekar, the two
Hmm.
investigators who have been looking at this very assiduously. They've even done some clinical trials. So they're at Baylor, and you can find them very easily. Maybe you can contact them and interview them. That would be a very interesting interview to have. My beef with them is that, yeah, they show this. They don't answer that question of whether it's better than glycine alone because they never treat with glycine alone.
Right.
At least not anything they published that I could find. So if they have anything like that, where they show that, yeah, with just glycine you get this, but with glycine and cysteine you get that. And the reason why I'm skeptical of the cysteine being that important, and by the way, when they give glycine, that you give about 10 times as much glycine as cysteine. Cysteine,
Hmm.
you need a lot less.
Mm.
But the cysteine is an amino acid that is quite abundant in meat, and it's also made from methionine, which is also abundant in meat, as I've been
Mm.
saying.
Yeah.
So the idea of there being a cysteine deficiency doesn't look that likely unless you have what's called paracetamol poisoning. Wow, paracetamol poisoning. How do you get that? Well, just take Tylenol and you
A
get a
lot of
little bit of
Tylenol.
paracetamol poisoning. Paracetamol is another name for acetaminophen. And that will destroy the glutathione by destroying, because glutathione is a tripeptide, 3 amino acids, glutamic acid, cysteine, and glycine. It's gamma glutamyl cystenyl glycine. It's a tripeptide. And so it has those three. So it has about the same glycine content, by the way, as collagen. So when
Mm.
people say they took, mega doses of glutathione and that really helped, I'm skeptical of those because it may very well be the glycine that's in it. Or, as Kumar and Sekar might say, it's the glycine and the cysteine in it. So that's the thing, is that you would not think that the normal American diet is going to be deficient in cysteine, an essential component for making glutathione, but for the taking Tylenol, and that's or acetaminophen, and that's pretty common. And a lot of people take a lot of it. And I don't know if that
Yeah.
feeds into it or not. But what I'd like to see from them is I would like to see the interventions where they try both of them separately, not just together.
I love that.
They point out they have what's called this law of three or this power of three, where you have the glutathione, glycine alone, and cysteine alone. They all have effects alone, and then there is the additional power of glutathione when you put the two together.
Hmm.
But so I mean, I would think the evidence that I'm familiar with, all that I know of, still points to glycine as the one key rather than cysteine. Although I would say what I always say to everybody, if you're going to take Tylenol, if you're going to take acetaminophen, especially if you're going to take it on a regular or semi-regular basis, always take NAC with it.
I love it.
NAC, which is N-acetylcysteine, or you can take just cysteine by itself. Either way, it's usually sold as NAC. But you really shouldn't take acetaminophen without it because it does deliberately and specifically destroy the cysteine part of glutathione. And that's not good for your liver.
No,
So
good.
that's why
Thank
it's known to be hepatotoxic.
Yes, and thank you for that. And then one other question is someone mentioned, and I didn't even put this on your radar, but I'm wondering if you know, they said that 500 milligrams per kilogram was shown to create a glutamate toxicity. Have you ever heard that? Because I know much higher doses were used in schizophrenia.
Yeah,
Um,
well, 500 milligrams per kilogram for the typical 70-kilogram man, I mean,
yeah,
I'm about 75 kilograms, so that would be about 37 and a half. Uh, that's about 4.5 times what I would put in what I put in my 8 grams a day of sweetamine, right?
yeah, like
So
way more.
that's a lot. That's a
It's
lot.
it's a lot. Have you ever heard about that research?
No, and
It's almost
I've taken
impossible.
just about that much, and what do they say it causes a glutamate?
Toxicity, I believe they mentioned a glutamate toxicity, and then they were like, "Oh, you guys didn't mention that in the podcast." But just to know, that is a huge amount. Now, doses like that have been used in schizophrenia. I've seen that. I've seen
Yes, they've
research
used
that
60
suggests,
milligrams, 60 grams a day
yeah,
with it. And I said I've taken 40 grams a day, no toxicity. And
okay.
I wonder why you would get glutamate toxicity from glycine because you don't make glutamate from glycine.
I wasn't
Uh,
sure. It was just that that was all that they said, and I asked
I don't
about
know.
research.
Yeah. I'm
And
not sure where they got it unless you see I would be happy to take a look at the source, but
okay, I love that.
I'm really not familiar with that and it seems unlikely to me.
Okay, and last question before I let you get to closing comments. Actually, two more autoimmune conditions. Do you
Yeah.
think glycine is a factor there?
Well, as I say, I think it's certainly useful for secondary inflammation that often accompanies those things. So, for
Right.
example, my daughter had a friend that she gave sweetamine to who had lupus,
Hmm.
and she said, "Thanks so much. This stuff is great. Now, when I get up in the morning, I can actually bend my fingers
Mm,
when I first get up in the morning."
yeah. Yeah.
Because, like it doesn't have anything to do with lupus, except again, lupus is the kind of condition where your own immune system is causing damage, and secondarily, that's going to produce inflammation. So it can certainly help. Like it helps in gout, for example.
Yeah.
If you have gout, it tremendously helps with things like gout um, flare-ups.
Yeah.
Because again, those are, secondary inflammation from the damage. Gout flare-ups happen when you have a crystallization of uric acid. And what do those do? Those crystals actually cause damage,
Yeah.
and then the damage secondarily causes inflammation, and that's what causes the pain, most of it. So that helps with that. So yeah, it helps with a lot of things. It's not meant to diagnose, treat, prevent, or cure any disease,
No.
as they say
Yeah.
with the FDA. It's because it's just a nutrient
Yeah.
that all of these things will happen more readily, earlier onset, and just generally worse, symptomatically, all of these things, and sometimes asymptomatically, like what goes on inside your arteries. You may not know it till you develop a heart attack after 40 years of it, right?
Yeah.
Um, so it will. It will help all of these things insofar as keeping your body and your nutrition whole and healthy is going to help everything. But it has these, all of the specifics about glycine make it very special, which is why I've basically devoted most of my career to it in recent years.
I think it's amazing. And we're going to do closing comments. Two last things. Can you feed it to pets? And if you had to design an experiment that you think would illustrate the potential for glycine, like what would that look like today?
Wow. The first part's very easy. Pets, yes.
Yep, you can do pets. Yay. Okay.
Yeah. I even have a funny Shark Tank story if you want. I remember there was a Shark Tank episode where there was a fellow who was, he was about 70, and he was a veterinarian, and he came on with his daughter who was also a veterinarian, and they had started a new line of pet food that they called cornucopia. I don't know if it's still in the market or not. Well, Mark Cuban went after him like crazy, quack and all this, because he said he went around the world looking at the populations that were the longest lived, from that island in Japan, Okinawa diet, whatever
Yeah.
diet that is, and places in, Scandinavia, wherever people live the longest, and looked at what they ate and came up with mixing all of these things. He came up with a dog food, which he then served to all the sharks on Shark Tank because it was fit for human consumption.
Oh.
And it was, they said, oh, it's pretty good, tastes pretty good. And it was supposed to be great, wholesome food. And he said, this will keep your dogs so that instead of dying of cancer at 10 or 11 years old, they'll live to be 20. It doubles their lifespan. They'll be much healthier. They'll live longer and all that. And so it sounded like a little bit of hype. And so Mark Cuban really went after him. So I felt really sorry for him because I thought it made sense depending on what was in this dog food, in this pet food. And my hypothesis was that his food is probably high in glycine. So I found it online. I look up
Oh.
cornucopia, I look up the food, and sure enough, it's got bone broth, it's got fish bone broth, it's got gelatin,
Oh.
it's got lots and lots and lots of these, so it's a very high glycine food. And
Oh.
yes, this is why dogs crave bones. I finally learned after all these years why do dogs like
Wow.
bones so much? Why they have to gnaw at them. Yes, it's good for their teeth, but they also get glycine out of it because they will, get some of that bone protein, that collagen, but it not enough. It's much easier to give your dog a little glycine. Again, they'll be proportional.
Yeah.
I mean, if you have a 100-pound Great Dane, 150-pound dog, 100 to 150 pounds, yeah, give them a serving a day of sweetamine because that's about what people weigh on average. But dogs, if you have a 10 or 15-pound lap dog, just give them about one-tenth of that.
Yeah.
Give them proportionally the amount, and they'll love it because it's sweet. If you sprinkle it on their food or in their bowl, they'll lick it right up, and it will certainly help them.
Oh, I'm gonna start doing that. My Charlie has bad hips. I hadn't even thought about it. I'm so glad someone asked that question.
Okay.
And now tell
Charlie
us.
Hips. I thought it was Charlie Horse. Charlie Hips? Oh, okay.
Now she's got dysplasia, my little
Okay.
baby girl. Okay, now tell us where we can connect with you, and then if you think a study needs to be done, I'd love to hear about it.
Oh yeah,
Or
that's
other
that's a
closing
that's a very
comments.
tough question, but okay, I'll give you the contact info first. Just go to
Yeah,
sweetamine.com, SWEETAMINE.com. We have a sale going on right now, but that's on like a 5 months or an 8 month supply for Valentine's Day.
nice.
New people probably won't want to try a whole 5 pack or an 8 pack, but just for you get the sample pack, 12-day challenge we call it, is only 19.95, and if you enter the promo code autumn, you'll get $5 off.
Nice.
And so that's only 14.95. And even so, if you buy a whole box, if you want to try it for a month, that costs 47.80 with the shipping, but it's $5 off of that, so it's like 42.80 for a whole month's supply. Either one, if for any reason at all or no reason at all, you just don't like it, just tell us, call us, email us, and you get your money back. No empty box or anything. It needs to be.
And Dr. Brind, will you do me one favor? Will you stop sharing your screen so that we can close this
Oh, I'm
together?
sorry.
No worries. I just now
Um,
realized that
Stop
probably.
share. Yeah. Otherwise, you see people overreact like those Kupffer cells,
There you go.
rat
Now
liver,
tell us.
rat liver macrophages. Yeah. So anyway, so now the question is, what experiment would I run?
Yeah.
What experiment would I run? Well, the question is, what would I be trying to prove?
Yeah.
So, I mean, I believe that I've done some research myself. I worked with the NIA feeding experiments showing that glycine increases the lifespan of mice by about 5% on average, even if you start it once they're mature. I could share my screen and show you that one too,
You can
actually.
show me. Please
Yeah, all
do.
right. Well, let's do that. You see that? So this is I was a so-called sponsor. What you do is the National Institute on Aging, which is one of the NIH institutes, has a program called the Interventions Testing Program. So if you have something that you would like to introduce to intervene in the diet of animals, this is the kind of animal research I really like. All you do is you just add something to the food that the animals get to eat, the rats or the mice. In this case, it's mice. You just add something to the food that they don't mind eating, and that's it. You just take care of them, and technicians in animal research places they all treat them like pets pretty much, and they just get to live there in their cages, and they live a normal lifespan. And then when they die, you do an autopsy, and you see how long it took them, how long they lived, as opposed to the controls and so forth. So they have this, you send in it's basically like writing a grant proposal, but instead of getting money to your institution to run the experiment, they have it set up. So the NIA has it set up with three institutions. It's the Bar Harbor, the laboratories in Bar Harbor, Maine. I forget which animal laboratories there are in Maine with Health Sciences Research Center in San Antonio, University of Texas, and also University of Michigan. It's the Jackson Labs in Bar Harbor, Maine. So those three labs, and what they all have large populations of the same strain of mice. And when I say the same strain, this is a carefully outbred strain because instead of getting an inbred strain, so now you have idiosyncrasies of the strain showing up in the research, you have sort of Joe average mice, Joe average mouse, Joe and Jane average mouse, males and females. So they did it in males, they did it in females separately. They did it in this outbred strain of mice. You run it with a large number of animals, like hundreds of animals, simultaneously in these three separate study centers. What's the point? That way, in one lifespan of a mouse, 3 or 4 years max, you will get data from three separate experiments done in three different places using exactly the same protocol and the same organism.
That's
So
cool.
this gives you significance. And it's not often that you have an intervention that gives you significance.
Mm.
So here we have, um, yeah, so now we have, these are Kaplan-Meier curves, which are survivorship curves. On the y-axis, you have the proportion of the population that's still alive
Mm.
at any given time, 200, 400, 600. These are days. Age in days. I don't know why it says C here. That's age in days.
Mm.
So the longest is 1,200 days, which is about 3.5 years,
Mm.
right? The median, where 50% of the animals are still alive, is about, right? It's about 880, so it's about 2.5 years. Two and a
Mhm.
half years on average, 3.5 years max. That's the lifespan of these mice under standard laboratory conditions. And when you feed them, we had like 8%. What do we have in the diet? Median lifespan increased by 5% versus control, and 3% was the maximum lifespan increase when you combined, and this is interesting, this is important, when you combine males and females in
Mm.
all three study centers, that's six populations of mice, large populations of mice, you got this difference. The red ones are the ones that had 8% glycine in their feed, and the ones in blue here, that's the control population now. So the difference was about, on average, 5% increased length of time. Just think about it. If the average lifespan of a human being is 80, 84 is better than 80.
Yes, it
That's
is.
not insignificant, right?
No, it's
And
not.
why is the difference? They say, well, it's not a great difference. Here's another experiment. Here's one experiment I really wanted to run, but I can't because of the constraints of this so-called interventions testing program. And because of the fact that it's really good animal research and kind to the animals animal research,
Yeah.
what about let's do a control population where they get no glycine in their diet, right?
Mm.
Because it's supposed to be non-essential. Your body can make it.
Right.
And what my hypothesis is, the result would show that those controls who got zero glycine would not live as long,
Mm.
right? Because they're
Yeah.
getting, it's a little like the Cruz study. It's you got to find a significant effect on these diabetics who are already being medicated for the diabetes.
Right.
So here you're doing it on rats, on mice in this case, to show that they're getting the benefit of that extra nutritional ingredient when they're already getting, guess what? 2.3%
Mm,
by weight of their diet is already glycine, and
yeah.
you're just raising it to 8.
Nice.
So they're already getting a lot of glycine in their diet. And, from a scientific point of view, gee, it would be nice to see what would happen if they didn't get any. But I don't think the rats would be as happy or as pain-free or anything like that. So bad, Dr. Brind. Don't do animal research. Don't even think about doing animal research that's going to make these animals suffer, which they might. But
Yeah,
from a scientific point of view, you can see these limitations
right.
just from an ethical point of view, based on, how to treat people and how to treat animals. You can't, you can't push the limits of the science because science is usually let's try zero and let's try, some amount. You gotta, you gotta start with where they are. Now, in the
Right.
case of people, we all have glycine in our diets. We all have 2 or 3 grams a day, and it's not as much as 8 grams a day. In the same way, this is 2.3
Mm-hmm.
versus 8. So
Mm-hmm.
it's almost the same
Mm,
arithmetic going on, almost the
mm.
same math in terms of making the diet better.
So you say we're gonna
Red
live 4 years longer. Just kidding. I'm just kidding.
Well, what's
Nah.
that?
I said you're saying if we take glycine, we're gonna live 4 years longer. Just kidding.
The
Yeah.
funny thing is, here's another thing, and I'll answer another question that gets raised in a lot of these comments because the question of cancer comes up.
Yes,
And
always.
so it's not going to cure cancer or prevent cancer. So what case in point, why do these animals die after 3.5 or 4 years? Why? Most of them die from cancer.
Mm,
Because cancer used to be, many years ago, used to be one of the reasons that people died of old age. They get some kind of cancer in their 80s and 90s, and they're frail anyway, and it does them in. So is the case with mice. In the case of these mice, most of them die from lung cancer.
mm,
And what happens is the lung cancer, the tumors grow and grow and grow, and eventually they grow so much that they can't breathe anymore, and that's how they die. They die of
mm.
asphyxia because the tumor is too large and prevents them from
Well,
breathing. So, I mean, and we don't do any intervention, right? That's not part of the research. You just let them live as long as they live. So I presume if you did some medical interventions, you could make them live longer, just like you would with people and pets. But the so the and the hypothesis there in terms of why that happened, and that was a significant finding also in this research, is that the tumors didn't grow as large because glycine is also anti-angiogenic. It helps it suppresses the ability of tumors to grow a new blood supply, which
mm,
they need to grow their tumors. So that's presumably why, and that actually corroborates research that was done on mice using transplantable melanoma tumors. That if you give them glycine, the tumors can't grow or barely can grow. Um, so the tumors become all of a sudden they're not transplantable if the mice you're giving them to have been supplemented with glycine. So this kind of bears that out. So it doesn't, again, it doesn't prevent or cure any disease. It just helps to prevent the kinds of conditions that either lead to disease or produce the painful or uncomfortable symptoms of disease, the pain and immobility of something like an arthritis or a lupus because it secondarily stops that inflammation because it keeps everything otherwise truly healthy so that disease probably won't happen when you're as young, probably won't be as severe, won't, all things like that, because it's not a drug. Again, it's just a very, very key nutrient. And I'm so glad that there is now so much time being devoted on the internet. I'm going to stop sharing,
yeah.
at least stop sharing the screen. And then, so that's why I'm just very happy to talk about it at the drop of a hat. So
Yeah, well, Dr. Brand, that was one of my favorite discussions of ours yet. So thank you. We busted so many myths, and I think you made it very clear that you're not here selling glycine as like a fix it for everything. You're saying this is a nutrient. Many of us are deficient. It has some
yes, so
powerful impacts.
so
And
it will fix everything you have that is a result of that deficiency,
exactly. That's
which may be nothing.
yes, right.
You,
And
you
could be
know,
a
and in
lot of
which case,
symptoms.
The people
Yeah.
say, well, I drink a lot of bone broth, and I'm taking your supplement too. I said, well, you really don't need to take both of them, probably.
Yeah, I
You
mean,
know.
or you could, I mean, like it's not going to hurt you if if you
Or
do
you know what?
probably.
Another thing they'll say is that somebody says, can I take more than one of these if one doesn't really do the trick? I'll say yes. There are some people who say, I remember this particular one customer at plantar fasciitis. She said, I took one and I think it's helping a little, but it's not really going away. Is it? Can I take two? I said, yeah, you can take two. It doesn't hurt you. So she took two and she said, that did it. My plantar fasciitis is gone now.
Wow.
So I've had customers like that. So I've had other customers say, okay, well then I guess should I just start with two? And I say, well, why don't you start with one? Because
Yeah.
if I tell you to start with two and it works, now you're going to take two. That's great for business. I'll sell you twice as much Sweetamine, but
Yeah.
you really don't need, and it won't hurt you, but you really don't need it.
Yeah, and I always
So,
like to advise start small, right? And just see
right.
what your body needs, find your optimal dose,
Yeah, some
especially
people, one last thing, as some commenters have said on the internet, well, I think two or three is a good thing to start with. It may be much safer to start with two or three and not start with, 8 grams a day or whatever. And to which I say 8 grams is not that much and it won't hurt you anyway. Yes, there are a few people who will get GI symptoms from it. They'll get
yeah.
diarrhea from it. They should just have bone broth or gelatin because that requires digestion, so it's not absorbed so quickly and it doesn't have those GI effects that a very small minority of people will get from it. But any effects that you get from it, any ill effects, they'll go away if you stop taking it or if you break it into smaller doses, that's fine. But you don't have to finesse it too much. That's why I love selling this stuff, and I haven't gotten in trouble. Nobody's gotten in any kind of trouble or have any harm done to them in the 18 years that I've been selling it.
It's crazy that
So
it's 18
it's
years.
tens of thousands of people. That's
Yeah.
that still isn't that big yet as things go, but maybe if we just look at glycine supplementation as a whole, it's getting bigger and bigger. Like everybody now is selling magnesium glycinate,
Yep.
right? Magnesium's the latest craze, and I see ads on TV every night. One brand of magnesium glycinate from Cunol, another brand of magnesium glycinate from Nature Made. Buy our magnesium glycinate because you need magnesium. Well,
You
magnesium
do.
glycinate is 86% glycine.
Yeah.
So when you take those two big pills to get your 200 or 300 milligrams of magnesium, you're getting about another 2 grams of actual glycine,
Isn't that
which is not really enough for what most people need every day, but it's enough to feel the difference.
Yeah.
It's enough to feel a difference, and you can do it as part of your regimen if you want to get the magnesium, take magnesium glycinate, but understand that you subtract that from the 8 that you need and you don't have to overdo it for anything, whether it's a drug or not. Unless it's ice cream. My wife will tell you, ice cream you can overdose. That's okay, but not anything else.
Okay, well, we got to end on those words of wisdom right there from your wife. I love it.
Okay.
Well, thank you, Dr. Brind. I'm sure we'll do a part four eventually. And thank you everyone for watching and your questions and this like wonderful scientific discourse. I welcome it all, and I'm just glad that we could provide some clarity. So thanks, Dr. Brind.
Okay. Well, thank you again for having me on. I really do appreciate it.
Always
And have a
fun.
wonderful day.